Record ediyor muyuz? Evet ediyoruz. Hello and welcome to another episode of where we're trying to manipulate some stuff to manipulate our brains. What a melancholical. So this was the website that I gave you to have a look at and run some code in it. Because if you are going to you're going to be preparing for the computer Olympiad, computer science Olympiad, maybe we might call it, and not much programming experience is needed to complete through that exam. And so we don't need a real world computer, a real world program running on your computer to practice the questions that are going to be asked in the exam. Excuse my bad English, I'm a little bit tired right now. So we're going to be using this for the rest of this lecture series, but I will be writing the code on my own IDE here on my computer. If you want to set up an IDE of your own to your computer and do your stuff, even more advanced stuff like writing an actual program with it, I am of most assistance. You might contact me whenever you want, but throughout the lecture series, my homeworks to you will be defaulted to this system. And we also, Mer Faruk told me about this classroom system that they built up here. And if you click the link we shared on WhatsApp, you may enroll in this classroom. And I guess it's kind of like Google Classroom where we can share homeworks and check them, but I don't know the details yet. Maybe we won't even use it. But let's get back to being familiarized with the interface of this website so that we can get rid I can get rid of that as soon as possible to return to my own IDE because I hate JavaScript and I don't want to see it on my computer running, especially for such an honorable purpose as running C code. So this is the example code that it gives us when we first launch any project. If also that text, whatever above that line, that include line, is a comment. Comments are usually used in software to indicate or document a program to make the readers of the program easier to what I'm saying to make it easier to read the code by someone who may want to be familiarized with it. For example, I may include a comment here like so. This prints, what am I doing? Uh, this prints hello world on the screen. Like I can insert a comment here and it will not be executed. It will be overlooked by the compiler when compiling this to the machine code. But when reading as a text, when reading the code as a text, it will appear slightly grayish to indicate the reader of the code that is a comment, and it would explain him or her what the line behind it or in wherever it was put is supposed to be doing. And we write comments in one line like so by putting two dashes, not dash, slashes at the beginning of the comment. And if you want to include a multi-line comment, you first want to put this combination at the beginning of the line of the comment, and at the end you must include this, sorry. And then you can type whatever you want, even the lines that are the boundaries that these symbols are included of the comment, and it will be disregarded by the compiler and will not be seen as errors however you type them. And this also is an example of a comment which reads, welcome to GDB Online, which is GNU debugger. GDB Online is an online compiler and debugger tool for C, C++, Python, PHP, Ruby, C Sharp, OCaml, what the hell is that? VB, Visual Basic, Perl, Swift, Prolog, JavaScript, Pascal, COBOL, HTML, CSS, JavaScript code, compile, run, and debug online from anywhere in the world. Now, GDB is GNU debugger. GNU, you might know about that project. I opened the Emacs documentation. GNU is the abbreviation for GNU is not Unix. It was created, it's a project, actually a philosophical movement created by Richard Stallman, a free and open source software activist. That philosophy is created by him, which states that any software that is created must come with a source code so that a user can verify what it actually is doing on someone's computer. So, for example, we all know that Google and Facebook and those kinds of big tech companies track us by inserting code, malicious code in their programs, but we are unable to verify that because we cannot look at their source code. So they are basically unreliable, malicious software on your computer residing there just freely and untouched. But if you were to open source, free and open source everything, every piece of software out there, we would be able to look at the source code of the software before installing it to verify that it does not do anything that is malicious to our computer. That is something that we don't want it to be doing. And yeah, you might ask, every time I would install a software, do I have to check its source code? Of course not. The software, open source software projects are widely checked by the community out there. Like someone wonders and has a look at the source code, and when he sees something or she sees something malicious, they would immediately make it public that this software is unusable, and this system has worked pretty much greatly in the last 40 years of free software movement since it existed in the first place. And this is the idea behind it. And also, this is the open source part. There's also a free part, which is explained by not as in free groceries, but as in free speech. The word is used in that context, which means that any software that is distributed with its own source code must also be given the ability to be studied by other people and be modified with it and created upon. Like, for example, I take a piece of software from a company and I build on top of that and I publish my own software through this. A great example for that would be Linux. Linux is a free and open source software, and Apple comes and builds its own operating system kernel on top of Linux, which it then calls Darwin, which was also an open source and free project, and then it converges to something proprietary, which basically means anti-free software, but it started as such. And there are other famous examples like WhatsApp being derived from Signal, Chrome being derived from Chromium, etc. And you might ask, how do we earn money if we make it publicly available, every part of our software? How do we make money then? Everyone can just freely distribute it. Well, this is a lot deeper of a question, but through the internet, means of internet and subscription systems, free and open source developers are able to gain money with their software, but of course not as much as the proprietary ones. And I think Richard Stallman, by creating this movement here, creates a balance between the malicious and non-malicious software so that we are not truly addicted, reliant upon companies tracking us. It sort of sets a barrier to a certain point, which would eventually probably be blocked anyway, whatever. So the GNU project comes out as a movement to create alternatives for the proprietary software that was the only kind of software available back then. Today, most software is free and open source thanks to the community's heavy efforts towards doing that. But back then, most software was proprietary. Not most software, every software, every piece of software was proprietary. And he wanted to first create an operating system because that's the most basic thing of software. Without it, you cannot do anything. And he called the project GNU. Is not Unix because Unix was the best operating system as we've talked about before, but it was proprietary. So he was trying to create an alternative to the Unix, but it would be GNU, not Unix, which would be free and open source, and which event this movement eventually created the birth of GNU Linux systems, because Linux is actually only the kernel, and every part of the operating system usually in the Linux distributions comes from the GNU project, GNU set of tools. So it's more technically accurate to call them GNU Linux distributions. This is widely stated by GNU activists. But yeah, in real life, most people just call them Linux distributions. So GNU Debugger is one of those programs that are distributed via GNU toolchain, GNU set of programs. And what a debugger does is that it allows you to navigate through your code while it's working to look for any kind of bugs, any kind of errors. But we'll not be using a GNU debugger or any kind of debugger because we will not be writing any advanced programs here. I'm just trying to clear things up, okay? Now have a look at the first line. Actually, yeah, you write your code here and then you click run. And what, how can I do not detect that? You select the program C, and then it runs right at the bottom of the screen. This is a term, this may be called a console screen. You might ask, I was expecting the program to be a software, to be doing some graphical kind of thing, to be prompting me with a window or something. You might ask that to yourself or to us, and we would reply to you that it's a very complex topic which we cannot talk about here, because if we do, we would have to dedicate the whole lecture to that. But basically, for graphical programming, you would need different libraries because it is not the default of a program to do graphical things. It's many of the things that a program might do. A program is essentially a thing that tries to compute some things with a computer, and it may compute whatever the hell it wants. And in this case, and in most of the intro to programming lectures, we would be trying to print out things to the console, which is a text-based interface, not related to any kind of programming language, but it's related to basic operating system input IO systems. And yeah, it is just a better way to teach, a simpler way to teach, because it's the default that every programming language has been going for since the birth of the programming. A very basic and simple way to teach programming without making things complicated. So whenever we type printf, people usually say that it prints something on the screen. No, it does not print something on the screen. It just outputs a string, a word, an expression to the console. And if we are trying to get the output of the console on a screen, we might just as well display it. But it does not by default, display anything on the screen. It just sends this data through the channel of a console, which operating system recognizes as a console and sends it to the whatever the program is set to display its console. And if it wants, which in this case and in most of the cases is decided to be displayed on the screen as such. But remember, the program doesn't display or print anything to the screen. It just channels this data to the console protocol. And I think I might share a little bit of resource on this, a really great resource on this from the guy I sent you the day before. He's a really good explainer of things and he knows really well. I myself learned about terminals and shells through his channel, this playlist right over here. And don't be confused by the word terminals and shells. It is mostly the exact same thing as console that we've been talking about for the last couple of minutes. So let me check that and send this to the group chat here. And we can move on. I'm booting up my IDE right now. This is my IDE. This is Emacs. So yeah, find file. Actually, let's first make some directory. mkdir c lectures 3 that. And yeah, there we go. It's desktop C lectures and second.c because this is this second course, the second lecture in this course series. So we start out by including stdio.h, which is an abbreviation for standard input io.h. By the way, I'm going very slowly, as you can see, not like a fast-paced programming lecture that throws at you all of the commands you can use in a language. Is that a problem? Because I'm trying to explain things, how things work along the way. Is that a problem, or should we go faster because you have all the time till March?
Bence bu şekilde iyi gibi.
Okay.
Hı hı. Ya
If you feel any kind of misunderstanding or any kind of slow pacing or not understanding a topic at all, just please feel free to kesin benim konuşmamı ve söyleyin, tamam?
Büyük şeyi anlayabiliyoruz yani. Öyle düşünüyorum.
Okay. Detayları zaten öyle hemen öğrenemezsiniz. Ben de öyle bir kabiliyette
Hı.
bile değilim zaten. Onları öğretecek kadar
İşte
bilmiyorum. Now, let's talk about this include. How can I zoom?
we can see the first and second lines because yeah.
I'm actually trying to close this thing, but it would not, and it's always is blocking some part of my screen, and it annoys me. I saw that in the recording yesterday as well, and it really, really made me mad, but I cannot hide it. At least I could not find a way to. But is it okay now? You can see everything that's relevant.
Yeah.
Okay. Now include.stdio.h. Now include command with a hashtag at the beginning. Now this hashtag, for those of you who know Python, in Python it means a comment, like the one we've talked about C. But in C and C-derived languages, actually, C has become a family of languages, which includes C++, C Sharp, C++. I guess there was a language like that. C, C Sharp, and lots of C's out there, but the only acceptable thing is C, in my opinion. Include means with a hashtag at the beginning is to include, of course, a library in the computer, which is, as you might recall from the previous lecture, a set of functions maybe defined in a file that we use repetitively on some various programs in our software, because standard io.h contains some of the most essential functions that a program would want to use, that we would not want programmers to rewrite it for every kind of program they write over and over and over again. We just created one library right when the C had started, back around 70s, and it still to this day the same library as it had been, and it has been included millions and billions of times in various programs that are compiled and now running on every piece of computer hardware that is out there. Why? Because, as we've said, we don't want to rewrite things over and over again, and also compatibility issues. For example, I might write stdio.h in my own way, and you might write that in your own way. And when both of our programs are running inside the same computer, they may conflict each other because stdio.h contains essential functions that are constantly in touch with the operating system. So if they are not compatible with each other, they may conflict in operating system queues, and also they might do things differently that the user was not intending to. Also, they might not, the writer of the program, the programmer of the software might not know all the details of the operating system they're going to be working on. The programs are operating system specific, by the way. They're compiled specifically for the operating system and the hardware structure. They might not be that familiar with the operating system, so they write something wrong and the program malfunctions. On the specificity of programs on operating systems, well, there's some things called syscalls, which are essentially the operating system's way of giving computer programmers a way to communicate with hardware. For example, most famous examples of these are open. Open function, if you use Python, as you know, opens up a file on your computer. Bir dosyayı açıyor bilgisayarınızda ve onun üzerinde işlem yapmanızı sağlıyor. This is a syscall because it interacts with the operating system and sometimes with the hardware. In this case, always with the hardware because it opens up some file from a drive or something. But syscalls are essentially the ways to interact with the operating system to do something specific on the computer rather than the specific, the general things like summing and subtraction that are present in every kind of programming language. These syscalls are specific to the operating system and is provided by that operating system. When you're programming the stdio.h, you would need to be writing it down so that when the program is compiled for Windows, for example, the open function would call the relevant syscalls of the Windows rather than calling for the Linux syscalls, for example, because they might differ a lot between the operating systems. The Linux one might require a different argument. The Windows one might require a little bit more tweaking to implement. There are lots of differences between operating systems. So stdio.h must create an abstraction, as we've talked about in the previous lecture, that the programmer would not need to think about how the underlying operating system works and would write such a program that when it compiled, it would be compilable to every type of operating system, because in the compilation process, stdio.h would replace the open function with whatever the relevant system call for the target operating system is at the time of compiling that program. Yani compilation esnasında, yani bu kodu makine diline çevirme süreci esnasında stdio içindeki bazı spesifik kodlar, detayına girmiyorum şu anda. İşletim sistemi, o an hangi işletim sistemi için compile etmesini söylediysek compiler'a, ona uygun olan syscall'ları çağıracak şekilde ayarlıyor bu open function'ını.
Ben syscall'u şey yapamadım.
Syscall dediğini nasıl örnek veririz biliyor musun? Bir listesi var mı? Bak mesela bu listeye bak. Bunlar
Evet.
işletim sisteminin programlara, yani programcılara yazdıkları yazılımlarda kullanmaları için sağladığı bu stdio kütüphanesi aracılığıyla genelde sağladığı fonksiyonlar. Bu fonksiyonları kütüphaneden
Ha.
alıp kendi içinde kullanabilirsin. Bak mesela open bunlardan biri. Dosya açıyor. Read bunlardan biri. Dosyayı okuyor. Rename dosyanın adını değiştiriyor. rmdir bir tane klasörü siliyor gibi.
Siliyor.
Böyle böyle şeyler yani direkt işletim sistemiyle etkileşime geçmek için işletim sisteminin oluşturduğu fonksiyonlar. Bu fonksiyonlar işletim sisteminden işletim sistemine bu tabloda da görebileceğiniz üzere değiştiği için compilation esnasında bizim hangi işletim sistemine yönelik çalıştıracaksak, compile edeceksek o programı bunlardan uygun olanları o şeyde programın içerisinde include etmemiz lazım. Yani C programcısı her zaman open yazacaktır. Burada kendi dosyasının içine, kendi programının içine. Fakat compiler bunu compile ederken bu open'ı mesela Linux'ta e, nedir? Neredeydi bizim open? Open'la değiştirilecek veya atıyorum burada başka bir şey olsaydı Open F olsaydı Darwin'de onunla değiştirecekti Darwin'e compile ederken. Anlatabiliyor muyum?
Hı hı. Anladım. Tamam. Şimdi oldu.
Bu syscall'lar bu şekilde çalışıyor. And thus, this is another benefit of having libraries, standard libraries on all computers because they remove the need to write operating system specific code, and your code is compilable for every type of operating system and architecture there is. The details of that are handled by the compiler, as we've said. And what you might ask is standard input output is. It is basically inputting and outputting to console and to files and folders inside the computers. There's nothing more than that, at least in the basic level of understanding. Now we include that. You don't have to include that, but in most of our programs, we'll be using printf. As you know, are familiar with the programming. We'll be using printf, and it would be located in stdio.h. These libraries are by default installed on your operating systems because they're standard. They're called the standard input output. They're standard. Without them, you cannot do most things. Even opening a basic file requires that. In Python, you might say for the open function, we don't need to include that because the answer to your question would be the Python already does that by default for you. That explains, that puts it clear that we need standard input output every time we write a program. So we put it on top. As we've said yesterday, the linker, when compiling the code, will copy and paste all of the contents of the stdio.h at the top of the program for the compiler to compile them along with the computer, along with the software we wrote. And if you were to, let's say, for example, put that in here, it would paste the contents of the stdio.h here and our printf above the include line because the copy and pasting was done, thus the definition of the printf function was done after the printf was called, would not be able to run, but the second one would be. Like so, we may show that to you. Now, ignore what I'm typing on the bottom. I'm basically compiling the program we wrote here. The GCC is the abbreviation for the GNU-C compiler. Again, it takes the output of second.c, which is the name of this file, and then it takes the name of the output file that it is going to produce, the executable, the final executable that is designed to be executed on Linux systems who are 64-bit, because that's what this compiler defaults to when it's run on that system. When you run that on your system, it will default to whatever the configuration of system you have on there, your hardware and your operating system. It will default to kind of compiling of that. Right now, in my case, I have a 64-bit computer with Intel's x86 architecture, which is running Arch Linux kernel, so it will be producing a binary for that system, but you don't have to worry about these details. In these stages of programming, all of these things are going to be handled by your helpful assistant here at onlinegdb.com. Yeah. They made programming a child's play, and now it is. Let's run that. So it gives out, what is this? How can I? It gives out the errors here. Second.c, you have to be good at reading whatever the hell something outputs you. When you run a command in any type of computer, you would need the ability of reading and figuring out the problem by yourself, because that's one of the most essential qualities of a programmer, being able to read the documentation. We will tell you to read the documentation for something you asked to us about, because that's the most efficient and problem solving and analytical and basic way of handling with something. That documentation isn't there for fun, and it requires you to use your brain, while asking us it does not. And the second important quality of a programmer is to be able to solve problems, of course, through step-by-step problem-solving abilities. And thirdly, it is to self-teach himself or herself through researching and craving for knowledge, and maybe spending hours on a simple bug that will eventually teach him or her lots of knowledge. So you'll need to be able to read these. Let's have a look at that. Before asking about any kind of bug or some error you get when running a program, first and foremost, only and only read the error message of the program, because they're designed to help you solve the problem, not help you solve the problem. They're designed to solve the problem. Over the years, we started treating messages like there's some kind of thing that is randomly outputted there, and we ignore them. But they're the only way. They were the only way back in the day to solve a problem, because they're the thing. They're the explanations of this code, of this thing, and the documentations also. But today's people are reluctant to use their brains to solve some kind of problem, and they just, go with the fastest way, which is also connected to how we talked about people using JavaScript yesterday to do tasks inefficiently. The hardware grows exponentially, but the software requirements grow exponentially, and in the end, we get nothing changes. You just pay more money for more hardware that will run the same kind of software that you were running before, but more bloated. Okay, yeah. Second, let's see in function main. So we have a function main, and inside that we have an error. Second.c 4.3. Now, what does it say in the line 4 and in the column 3? Like you can see that this is the first column, this is the second column, this is the third column. Column is sütun, yani dördüncü satırın 1, 2, üçüncü sütunu. In 4.3, error implicit declaration of function printf hello world. This basically means that you have called a function here called printf, but you haven't declared it anywhere in the code before, which means you are calling a function printf, but there's no such thing. In programming, you need to define some things to then be able to access them. For example, if I'm trying to print out a variable here, and you know what I'm doing, I'm just trying to print out a variable. And before doing that, I wrote the name A here. The name here exists as A, but I haven't defined it before. So how the hell program would know what the hell is A? The same thing is valid for the printf as well. I haven't declared, I haven't told anything about the printf function to the program so that it doesn't know anything about it. So it is not able to do call printf because it doesn't know anything. Don't assume that because it is in the standard library, the C by default knows everything about it. The modularity principle requires that the programs do whatever they're supposed to do and not more than that. The compiler doesn't know about the existence of a standard library that is to be used in most of the C programs written. It does not aware of that. It is not aware of that. And unless you include that standard library within that, the GCC will not recognize the printf as some sort of a default must-use function that is used everywhere in most of the C programs and include it for you. No, it will not do that. You must include it before using that function. And yeah, it just goes on to say that incompatible implicit declaration. Yeah. It basically tries to understand why we're putting printf here, and it tries to be helpful. You might just as well ignore it. And then finally it says include stdio.h or provide a declaration of printf. It also is a helpful description. Normally a compiler, as we've just said, would not do that. It is not aware of the standard IO library, but you know, for the purposes of helping people, they just put that, you know, if you include the standard io.h, you would not encounter this problem. So whenever it sees a problem, the compiler quits. A compiler works by first starting at the first line of the program and reading it through line by line and compiling every line it sees one by one throughout the process. So it solved this int main. So it created a main function inside the assembly file. It would then convert to machinery code, and it just wrote that. And then it came to printf, and it could not find a function called printf, so it stopped compiling here. It did not go below that fourth line because there was an error there that needed to be resolved, and without resolving it, it cannot put the machine code equivalent of that fourth line to the final executable. So it stopped compiling and asked us to correct that. That's why at the end, ZSH, which is my console, you might think of it as my console, ZSH says no such file or directory a.out. Because the compiler hadn't finished its job and created an output file called a.out, which is the machinery, which has to be the machinery equivalent of the program we just wrote above. Because it did not finish that job, there's now a file called a.out, and when we try to run the file a.out, it just says us there's no such file or directory. So we take it here, paste that. You write that again and run it. What? Yeah. Sorry, there was a simple GCC syntax error and we resolved it. And now you see we wrote on the console, not the screen, the console, hello world, and then hello world -2 and implicate whatever the hell this is called. Now you might ask if your intuition was that printf would put a new line, would, you know, hit enter before writing that second hello world 2. But it did not, because new lines to the human intuition may seem like a default kind of thing that you would use in a writing, but computers are not intuition. Computers are machines that are distinctively designed, whose every component is distinctively designed to do its job. And if you don't specify something, the machine would not assume something for you. It would do whatever you put it there. And everything is such distinctively defined that we are not leaving any space to be defaulting to something. And it is the case with that as well. If you're not putting the character of new line at the end of the string, strings are these texts, basically. At the end of the string you're trying to print, it would not print a new line. Yes, we say that new lines are printed. Just like I'm printing 1, 2, 3. When I print the character of a new line, it prints that, and then I resume typing. The new line is just another character in the character set of computers that happens to be interpreted in a display, in a modern display, as going one line down, one pixel down. But it is no special kind of thing. It is a character represented by a number, just like every other character in these strings above. In the computer's memory, everything is encoded in numbers, and this is no exception. This will be encoded in some kind of number. H will be equal to some number, and E to another number, and L to another number. And this new line character, we wrote this combination of backslash and n, backslash and n. What is backslash? Is also represented by another number in the final binary code. These definitions are done by ASCII standard. When first created, the computers were first created, scientists came together and decided that from now on, we will represent every character with the number that is given in this table over here. For example, B, I cannot read this. Yeah, like for example, 9, the character 9 would be equal to 57, and then H would be equal to 72, etc. Every character was defined like so. Only 128 characters, because the computers were all in English, the users of the computer were all English, and no special characters were required. But as the time went on, the computers became international machines that communicated between countries and languages. Only then they started creating new standards like UTF-8, which is the most commonly used today. It's an encoding standard comprising of a million characters, which include all the characters from the Chinese alphabet to the Japanese alphabet to the Turkish alphabet to the Arabic alphabet to the emojis. They're all encoded universally as one 8-bit a number. And when a computer sees that, it says, well, this is UTF-8, so I must assume every following number to be representing the relevant character defined in the UTF-8 table and display it on my screen like so. So this is how texts work. Let's try this one more time. Yeah, we see that it passed into the next line before printing out the second hello world. Let's talk about this int main then. Are we understanding things?
Yeah, actually, for me,
Nee?
I can understand. But just for me, I don't know the others.
Neyi anlayamıyorum?
I understand. I can understand.
Ha, okey. Sorusu
Evet.
olan varsa söylesin, bak vurguluyorum tekrar.
Yeah.
Okay. Let's talk about this int main function. As we'll see in the future, hopefully, functions in C are defined through the syntax. You put the code that you want your function to run inside these braces here. These are called braces, by the way. This, that, A function is essentially a block of code that you name, and whenever you want to execute that code, instead of writing that lines and lines and lines of code, like instead of writing that every time in your program, you just write the name of the function and then the code runs. Just like that. And the code, the syntax for a function is int main int a. The first thing in here is int, which is an abbreviation for integer, which is a data type in C. We'll see about data types in the future, but it essentially means that the function will return something of the type of integer. Integer is best translated to Turkish as rasyonel sayılar. Yok. Evet. Yok. Rasyonel tam sayılar. Evet. En tam sayılar. Evet. Tam sayılar. Integer is tam sayılar. Yani eksi tam sayılar işte, biliyor musun? Yani diyor ki this function will return the value of the type of an integer, and in parentheses it states that the function will require an argument, only one argument of the type integer, which will be called inside the function as a. The function has its own scope behind the program, and it will name its variables. However, they're defined in these parentheses. So I might increase number here, putting new variables. I can change the type. Float is ondalıklı sayı. It may either be negative or positive. I can write that down. I can, do this like so. That was an array, which we'll see about, I don't know what lecture. And the syntax is that, but why do we have a main function in the first place? Why do we have to name a function called main in a C program? In the main executable, in the final executable, the final program, there has to be a main function. When the CPU starts running a program, it will start by executing the function main, and it will execute only that. No other part of the program is going to be executed by the CPU, and the program, if the program doesn't have a main function, a function called main, the CPU will not execute that program and will simply give an error. And you might say, well, we have defined other functions and we called them inside the main function. Yeah, but they were not executed because they were there. They were executed because they were inside the main function. Only the main function from the beginning to the end will be executed, and any kind of code will be ignored. And you might ask, why do we write include stdio.h beside the main function then? Because it's actually not a line of code. It's a preprocessor statement, which is essentially says, as we said, to copy and paste the contents of the stdio.h to that document. And this is done before the compilation starts, before the final executable is created. So the compiler actually gets this file, not in this state, but as in the state that this include line is, deleted, and instead of that, all of these stdio contents are written. So these actually is not compiled, and any kind of function declaration is only recorded in the memory of the program, as there's a function here, and if you somehow recall it throughout the main function, it's there, where it is, execute that and return back to the main function. Compiler sees that, defines a statement in the program that the function called function, or let me just rename that, the function called name, is there in that fourth line in the program, and when something calls the function name here, it just says, you know, let me just delete that and return back to name, and it just adds at the end of the function name, return back to main. Now, of course, these are very abstractions and metaphorical statements of how it actually works, but the basic idea is the same. So only the main function is executed. That's why its name is main. You cannot name this function anything else, and you cannot name any other function as main. Main function is only one, and it is mandatory for a program to run. A C file might not include a main function. If it's going to be a library like stdio.h, stdio does not run something. It only defines functions, as we just did with the function name. But if you are creating a file that is to be executed, which we'll be doing here for the most of our time, probably for all of our times, it's going to have to include a function called main.
I have a question.
Türkçe söyle, Türkçe söyle.
Tamam. Main string olabiliyor mu ya? Başka char bir şey olabiliyor mu? Ben onu hatırlayamadım.
Neresi char olabiliyor?
Ya işte hani integer türünde döndürüyor ya, onu işte mesela char türünde döndürecek şekilde char main yazdığımız zaman da çalışıyor muydu? Yoksa o matematik bir şey miydi?
Ne istersen. Öyle şeyler sorunca deneyin direkt.
Tamam.
Çalışır. Niye
Ama
çalışır?
niye biri döndürdü?
Ha?
Ama sen char bir şeyden integer döndürdün. O nasıl oldu?
Char integer'dır. Şöyle söyleyeyim. Char integer'ın yanlış hatırlamıyorsam 4 bitlik hali. Integer 8 veya 16 bit. Char 4 bit. Yani char da aslında sayı belirtiyor. Sadece biz kolaylık olsun diye ismini char koymuşuz ki genelde bir yerlere string yazarken, yani text yazarken, data tipini direkt ismi char olan bir şey koyalım. Ama aslında char bir sayı belirtir. Kesinlikle harf belirtmez. Harf diye bir data tipi yoktur zaten programlamada. O Python gibi high level dillerin işleri kolaylaştırmak için uydurdukları bir şeydir, ama yani öyle string diye bir data tipi yok yani. Onda öyle bir şey yok. Hepsi sayı.
Ben C++'da char diye bir değişkene sayı atayamam. Sayı integer'da da şey atayamam. Anlamına bakın mesela. Onu şey yapamadım.
Çünkü
Integer'da harf
ikisi
atayamam.
farklı data tipleri. Biri 4 bitlik, biri 8 bitlik. 4 bitlik şeye 8 bit yazamazsın sen. Ama onun sebebi birisinin sayı, birisinin harf olması değil. Memory'deki space'lerinin farklı olması.
Tamam.
Anladın mı?
Hı hı. Şey zaten TF8'den kaynaklanıyor.
And yeah, of course, inside of this function, you might state your arguments int, like text and sort of forgetting this language. So do that. Yeah, it will output this. Why? Because the argument part of the main function actually acts as it actually contains the arguments that you give it to it when calling the program from the console. Like, for example, in this line, the bottom of the line where I'm calling GCC, assume that GCC is a C program. This second.c will be given to the first argument stated inside this main function, and then the a dot and then the dash o will be given to the second argument stated inside this main function, and then the a dot is as well. So the arguments you give on the console to the program when calling it are given to those arguments defined within main function's definition so that you can use them by calling their names inside the name function so that your program is able to react to users' inputs when user is calling them from the command line. You might ask, in today's world, nobody uses command line, so what's the point of still holding it there? Actually, everybody uses command line because graphical interfaces are just interfaces for the end user to interact with a program. But when programs are interacting with each other, and the computer is interacting with programs, and the operating system is interacting with programs, the operating system does not move the mouse to click on something on the screen. Most programs running on your computer are just console-based. They just printf and take arguments through this main function's parentheses. And the programs communicate with each other through giving these names. Yeah, as a end user, you might not be using the terminal. Some users do, but you might not be using it. But this will not change the fact that most programs inside your computer are text and command line based and are using these arguments and these return values to communicate with each other, and they're calling themselves, they're running themselves from inside a terminal, which will not be visible to you as a graphical interface because, you know, every time a program opens up another program, it will not want to pop up a command line in your graphical interface, which would distract you from your everyday workflow. It just does that in the background. If you watch the playlist I sent to the group at the beginning of the lecture, you would better understand this concept. But know that programs communicate with each other through these means, which we might exemplify right over here with a very, very, very simple example. So this is the source code of the program that manages the windows, like the graphical windows. When I'm using my computer, like this terminal window is a window, this Emacs, this my IDE, this Brave, all has a graphical window. We call these graphical frames the frames inside of which the programs are fit. Their graphical components are called windows as a plural thing. And this DWM program manages, like, I want to resize my windows. I want to do this layout switch between windows. You can see they're highlighted in purple. Yeah. This program does managing of these sorts of things. And I have its source code here. Now, when I want to compile that, I am going to be running make install. Yeah, I'm going to be running this command on my computer, which would have a look at the contents of the make file, which is located right in the source code of this program, and it would execute whatever is running, is being written inside that make file. So let's have a look at that make file. You don't have to know about these make files and then, you know, compilation stuffs or anything like that. I'm just trying to give you context. And when we look at the compilation step here, actually, we don't have a compilation step. Where is it? We are calling GCC anywhere? No. So we haven't configured that. Okay. We have a GCC now. Oh, we have the CC. Okay, we have the CC. Right. For example, these are calling the chmod program. It's a program inside my computer that I can run here, but, you know, it says missing operand. I'm not giving enough arguments. These types of arguments. In this make file, it gives chmod command some kind of arguments for it to create the files that are documenting how I can utilize this DWM program, which this make file compiles into being executable. How can I reach this command makes the documentation of this program accessible by my user. You know, chmod plays with the user settings of a file, which users are able to access it. And, you know, it gives arguments to that program that, you know, this is a code for my user to be able to access that. And this is the file of the documentation of this DWM program. So it gives the name of the file and also the permissions. It will change to the chmod command, the program of chmod, to do its job. They communicate through arguments here, and this will not pop anything up in my computer while it's running, and it will does all of these things in the background. So this is absolutely necessary and no way outdated. Let's return back to this returning thing. Return is a keyword that is actually also very deeply rooted in operating system theory, but we can just basically think of it as a software's way of communicating with the other kinds of software what happened when it ran. Like, for example, if an error occurred throughout running this program, it will output 1. And if the error is related to, you know, a file permission error, it will output 2. If it is related to a network error, it will output 3. If it is related to Bluetooth, it will output 4. They will state what each of the return values mean in a documentation for their software. You know, as end users, we do not use much documentation, but the technical programmers do. They will state what each output, each return value means in a documentation, and by so, while communicating through programs, a program calling this program will look at the return value of this program to determine what it did while running to take action according to that. Like, for example, if a program is reliant on the second.c to, you know, modify the name of a file, for example, and this failed to do so, and then it outputted 2, and the upper program would know that the name of the file were not changed, so it would try to find another way to change the name of the file, because without doing that, it would not complete its job. So it's basically a type of communication between various different programs. I might see the return value of the last program through this last command echo. What is this that? I don't know. I'll check that. But there are better ways to check that, and you don't have to worry about that. It's just there to teach you why do we write these things, and it's also a convention to return 0 when the program executed everything successfully, and return 1 when something bad happened. And also we'll be using the return values of the functions, other functions inside of our programs, but the main function's return is a little bit different, and we'll explain why in here. So let's open this. Yeah, the last command I showed you here, which you don't have to know, outputs the last program's return value, the last run program, which was in this case a.out, which was the executable file of the program we wrote here. And it was, as you can see, again, 3. And you might guess why we don't have any kind of new line after that symbol is because we didn't put any kind of new line symbol, which I'm again emphasizing upon by showing you that the new line symbol is backslash n followed by n. And we might also be passing arguments to this program as to show that this text thing works. This and it returned that because 34 apparently means in ASCII that character it's outputted. 4. No, it's not that. I'm probably forgetting something. I am not in any mood to remember that right now. So let's move on. Printf functions, documentation, and as I've said, it has to be a reflex to look things up through internet documentations in English and also not through videos to when you want to learn something rather than asking someone or watching a video about it, because documentation's the best way, and certainly not asking to artificial intelligence. That's the killer of human intelligence and analytical thinking and brain. I am really against that, and in order for you to develop your problem solving skills, you must avoid that. So we'll be looking at this documentation together. So it says the printf function, the name comes from print formatted. It's a formatted string, a formatted text, which means I can do this and then it will put a variable there. Prints a string, which means a text on the screen. As I said, this is a wrong expression for me. Using a format string that includes the instructions to mix several strings and produce the final string to be printed on the screen, which essentially means it can combine various different strings, texts, and also put variables inside of these texts. Like, for example, in this example, the value is percentage %d, and then followed by a comma. There's counter here. This is saying that this percentage %d means a variable will be inserted right here on the text, and the variable, because this is the first kind of formatting in this text, will be the first variable put after the text ends. So it will output whatever the value of the counter is at the time of running this printf function. It may then change, but the output will not change. Languages such as Java include whatever. Printf is a special function because it receives a variable number of arguments. The first parameter is fixed and is the format string. The first parameter is fixed. It includes text to be printed literally and marks to be replaced by the text obtained from the additional parameters. Just as we said, this text is to be printed literally, and this variable thing, percentage thing, is a mark to be replaced by the text obtained from the additional parameters. Thus, printf is invoked with as many parameters as marks are included in the format string plus 1, the format string itself. The following example shows how to print the value of a variable counter. Let's exemplify that in our code by removing this, then doing that, placing that digit. These formatting things, what any character that is coming after the percentage means is listed in the documentation here as well. C prints the ASCII characters, the D and I prints the integer signed decimal conversion. Signed means eksi artıya dikkat ediyoruz. X unsigned hexadecimal, which is modüler aritmetikte 16 tabanı. P memory address pointer, bunu boş verin. E floating point conversion with sign in scientific notation. Yani ondalıklı sayı bilimsel notasyonda yazıyor. Bilimsel notasyon dediğimizde şu. Büyük sayıları bu cinsten yazmak yani yani bunların listesi var yani kısacası burada. Biz de hemen bunu programımızda yapalım dedik. Şu ikinciyi kaldırabiliriz artık. Save edelim. Çalıştıralım. Ne diyor? Text yapmışız. Evet. Gördüğünüz üzere text değerimiz 10'du ve burada da bize 10 şeklinde yazmış oldu. Ama dedim the symbol percentage denotes the beginning of a format mark. By the way, you might be asking why I'm not again throwing you commands. We're trying to teach you here how to read a documentation. The next lessons will be going more into the programming languages themselves. The mark percentage %d is replaced by the value of variable counter and the resulting string is printed. So before printing out the string, the formatting string is formatted with the variables coming after the comma, after the first argument. As we've said, functions require arguments when put inside of them, and these arguments are separated with commas. You know, I'm giving this an argument of text and then separating comma. If I had a second variable here, like again a digit, I would need to separate this again with this. Okay, a comma. Does this work, by the way? Yeah, it's working. The symbol \n represents a new line. By default, all output is right justified, that is placed on the right edge of the field, and by default the width of the field is the same width as the string length. So which essentially says the width of the field, I mean, it is starting from the leftmost column of the line. It's starting to print from that left column of the line, leftmost column of the line. This might seem intuitive to you and has to be the default for all of these things, but think of it as, you know, in the early days of computing, not before even the sort of normal printable published documents were not much available. These weren't default things. These had to be thought up from scratch in order to implement them, because, you know, there was a question how to implement this printing function and how it's going to print something. And then, you know, they did not have an answer because they did not print something before. So they had to come up with a standard. So the documentations followed also stating these choices of implementation. And today it might be obvious to you, intuitive to you, that the printing starts from the leftmost side. There can be functions and other kinds of things that do these formattings differently, and you would need to know the difference between them while programming your thing and while, you know, for your program to work accurately. Okay. If the format string includes several marks, they're processed in the same order as they appear, which is essentially means, you know, a first mark here, the first variable, the second mark here, the second variable, the third mark here, the third variable. The following figure shows an example in which the format string has 3 marks that are processed using respectively the string red, the integer 1 to 7, and the real number 3.14. No check is performed to verify that the number of marks in the format string and the number of the remaining parameters are consistent. In case of an error, the behavior of printf is undetermined. The marks in the format string must have the following structure. Fields in the brackets are optional. So this is how a mark is structured. First, a percentage sign that denotes that this following set of characters are a mark to represent these variables, and then flags. You might be putting up some flags. Do not concern with it. You will not, you know, use that unless you do some crazy stuff. Width and precision, which is what is used here. And lastly, length and type. You know, these are trivial things to further format your string, you know, to determine its width, to determine its position on the screen. These are really not that's concerning to you. And precision essentially means, you know, sometimes floating point numbers on the sayılar have many digits after the points. You know, this floating point is this. I can have all of these, and maybe it is infinite many of digits there after the point. And precision basically means how many of these digits after the point I have to include while printing this floating point number out. So if I say 2 for the precision, it will only print 3.14. If I say 3, it will output 3.144, like so. Thus, every mark starts by the percentage symbol and finishes with a type. Each of the names per meter flags with the precision, length, and type represents a set of possible values that are explained next. These are parameters, these are flags, these are width, these are precision, these are length, and these are the types, which are the main and things that we're going to mostly use here. C again prints the ASCII characters, passes parameters. So C expects, the mark C expects an ASCII character, and it would print that out. I wonder why it didn't before. Integer sign decimal conversion, as we've said, it's going to be signed means negatif veya pozitif olduğu fark ediyor, and conversion means it would convert floating point numbers to their integer parts. It will only display the integer parts. Skip that, and sign floating point conversion. If you are using, by the way, decimal means ondalık. If you're using, an integer value, passing integer value to this mark, it will convert it to a floating point number, which essentially means adding a point O at the end. So it will print the 4 as 4.0. Integer unsigned octal conversion, octal 8'li taban. Integer unsigned decimal conversion, yani işaret yok. X artı. Text string, we're gonna go back to this, and then finally, if you want to really print the percentage itself, you must put 2 of them. And it's actually true for many of other things in programming. For example, if you want to actually print a backslash and then an N after that, you will have to put 2 backlashes, because backslash, why do I keep saying backlash? It's backslash. Backslash essentially is the escape character, conventional escape character, which states to the computer that the character following me will be a special character that is needed to be treated specially. So be aware of that and do not print me out or him. Treat us as kind of a pair and do whatever has to be done conventionally. But in order to escape the escape character, to treat it specially, to treat it as simply as a normal backslash character, we need to escape it, as one does with the new line character here. And so as you can see, we just print out a backslash and N and no new lines here. Lastly, we're going to show some kind of thing and ending our session. Excuse me. And by the way, you have to put these semicolons at the end of every executable code, not preprocessor statements. They're starting with hashtag. All preprocessor statements start with hashtag, and other than this, and those kinds of function definitions, you have to put semicolons at the end. Okay, and the lecture may seem unstructured a little bit to you, because we didn't explain how to write a line, how to write variables. We're doing a helix structure here. This brings out this, then 40, and it's a parentheses. It's in the ASCII convention. So let's check that against the ASCII table. As we've said, the C character outputs the ASCII equivalent of the number you pass on to it. And have a look at the characters here to cross check it. Yeah. Like for example, it says 81 has to be Q, the capitalized Q. So let's check that. For instance, a Q, capitalized Q, and let's have a look at the decapitalized, the decapitated to Q. Why am I choking? Yeah, it prints that out. So it's based on the ASCII convention. You might ask, how are we going to write non-ASCII characters with that? And the answer to your question is going to be more bits using strings and integers, but the topic is not this lectures. Lastly, I want to show you how to handle an error, a basic error basically, to show the process in a simple way. So let's see, what can we do now? Yeah. Do this. Switch the places, the arguments. And this gives out an error second.c in function main, second.c, the 5th line, 10th column, error passing argument 1 of printf makes pointer from integer without a cast. So in this stage of your learning programming, you won't need to be researching this to solve this, because even if you do, you will not understand many of the things said. You will not even understand. You're not now understanding probably what the hell this message says, other than your intuition that this printf function's arguments are aligned wrongly. In this stage, you'll not need to. You won't research this because you'll not understand the explanations for why it's an error. But as you progress further through the programming, you will have to be researching every type of your errors through the method. In a second, I'll be showing to you, hopefully. But still, make sure to first research on the internet using this method in these early stages of your learning programming as well, to enhance your learning experience. Okay, so the first thing we do is read the thing, of course, and try to draw some conclusions from it. What does it say? Now we're not going to draw any conclusions because obviously, probably you're not understanding the thing pointer, maybe integer without a cast. These are terms we're going to be learning further into the lectures. For now, let's just copy that, paste it right over here. This is the second step in your debugging. Debugging in that it means getting rid of the bugs of a program. So you write that on the Google, on your search engine, not on your artificial intelligence program. You must use your brain. You must bring together the knowledge, the conclusions you draw from the error together to form a final opinion of yourself of what the problem is. This is how engineering works, how problem solving works. If you want to even be doing programming further into your life, future in your life, you must learn how to solve programs. And programming is an excellent opportunity for that because it does not require any more materials, any more budget other than your computer and your internet. So applying these problem-solving tricks in your programming sessions will increase your problem-solving ability. Will gain your problem-solving ability because right now we probably don't have one, or one that is quite weak. So let's open up the first reliable source here. You'll get to be familiar with the reliable sources as you progress further in your career. Now we know that Reddit / RC programming subreddit is a reliable resource. So a user posted this exact same error as us. Sometimes the error might not be the same as your case. In this case, you need to be more creative, more drawing conclusions, more interpretation based, not copying and pasting the exact same solution from this one to your computer. Even if it's the same error, you'll have to implement, apply, like adapt the solution to your specific kind of program. You'll need to be thinking critically. You'll need to be thinking, well, my error is that, I'm missing this. So let's research for that missing thing. So when you find this missing thing, oh yeah, that's that. I'll have to insert that into my program in a manner that it would work in it. You have to think about that. You're not wearing an eşek gözlüğü. You're trying to build your way into solving the problem. Now, it might seem trivial for such a basic error message, but believe me, in complex programs and complex error that takes up hours of your life to solve, this will be essential. First, read the question. I'm trying to run this code, which is just a basic calculator. It's just a warning and not an error, but gives me a segmentation fault error while executing. So here is his code. Printf doesn't work like you think. The first argument must be a format string. So you read this. You have a look at his printf. So his printf. What the hell does this guy do? Yeah, the error is here. You see that this is a bad question actually, because it does not state where the error is coming from. Which line does the error result from, but we would draw the conclusion that it's from this because it says passing argument 1 of printf. It says basically you're passing 1 to the printf as an argument. So in one of these printfs, there has to be a 1 or a variable that is while being executed can be 1 to make this program give out the error that printf takes the argument of 1 and which is something wrong. So we understand this. We draw this conclusion from reading this. So one of these is outputting 1, is being inputted 1 by the arguments it's being given. So the answering guy says printf doesn't work like you think. The first argument must be a format string, which is exactly what we saw while reading the first documentation, which I closed, I guess. But the first argument must be a string. But this guy put straight up the numbers to be printed on the screen. This is not Python. Even if you're trying to print the simplest thing, like so, in printf, you'll need to first write your format string, write it like so, and then give your variable to it. Or if it's a non-variable, something constant. But you'll have to first put your format string in there and then your arguments for the printf to work. So we drew conclusions. We tried to understand what this error message means. We first read it, we tried to understand what it means, and then drew some conclusions in our hands about what we're looking for in order to solve this problem, wrote that question on the internet, looked up some forums. There are some more detailed answers here. You can have a look at this if the first doesn't work, and then try to guess why the answers give this answer to that person, to adapt it to our own case, because answers are not answering our question, they're answering somebody else's question, but then we have to adapt it to our own case. Okay, this is the basic idea behind solving problems in programming, which you'll have to be using a lot if you do programming, not much if you do Olympiad only, but you'll see as the time progresses, you'll develop this method even further and become expert at solving problems and hopefully not be using artificial intelligence. Yeah, this is the end of the lecture, I guess. Any questions? Anything in Turkish?
No, sorun yok benim. İyi gidiyoruz.
Kafanızda oluştu mu bir şeyler?
Evet. Var.
Okey, o zaman kapatıyorum arkadaşlar.
Tamam yani. Hayırlı akşamlar olsun. Hayırlı
Hayırlı
geceler.
akşamlar.
İyi akşamlar inşallah. Faydalı olmuştur.
Sonraki dersimiz haftaya cumartesi değil mi?
Evet.
Aynı saatte. Tamam değişiklik yoksa tamam. Hayırlı akşamlar.